So now you should be getting quite used to sketching y equals f of x when we've done something to the f of x part. Now, rather than memorising a series of steps for each of these, we've got a series of steps that we can consider when we're doing it for the first time, but it's really important to understand what each of these sort of symbols means. So that way you're not having to memorise a procedure. You can look at each one freshly and think, now what have we done to this? And then follow some steps that really in every case are quite similar. In all of these, we've started with y equals f of x, and we've looked at that sketch first. And either you're going to be given that sketch, or maybe you're given an equation and you can start by sketching it. Then we're really just looking for y values, and we're looking to change them. So in this case, every time we find a y value, we want to take the square root of it. So if we can consider the square root of a bunch of different y values and then plot them by making small dots, then eventually we can join up the dots sensibly to make our new graph. Now, some things to think about. The square root of 0 is 0. So if you look out for x-intercepts on your original graph, they will still be x-intercepts on your new graph. So they're good things to start with. Put a dot on any of those. It's also worth thinking, well, the square root of 1 is 1, so that's a nice, easy thing to plot. That means that my new graph is going to go through my original graph at those points as well. But then also remember your perfect square numbers. If you know that the square root of 4 is 2, then look out for a y value of 4 and know that your new curve will have a y value of 2 for that x value. Those sort of round numbers will really help. Remember also that we can't take the square root of a negative number at all. So if y is negative, then f of x would be negative on your original graph, right? And so we can't take the square root of that at all. So that means that we can basically ignore anything that's below the x-axis on our original graph because those y values are negative and we can't take the square root of them. Now, other considerations, if you're looking at y values that are between 0 and 1, then what you'll find is that when you take the square root of those numbers you get are bigger than the original number itself. Now, let me give you an example. If I'm thinking of the square root of a quarter, say, then we know that a half times a half equals a quarter. So the answer to this question is a half. So that means that on our original graph, when y was a quarter, once we take the square root of that, we actually get a half. So our new graph will sit a little bit above the original graph when the y value is somewhere between 0 and 1. Whereas once we have y values that are greater than 1, when you take the square root of bigger numbers than that, you always get a small number. I mean, you know this to be true. The square root of 9 is something smaller than 9. It's 3. The square root of 16 is something smaller than 16. It's 4. So that makes sense then that your new graph is going to sit below the original graph as soon as your y values are bigger than 1. So let's have a look at how this plays out, and we'll start by working with that same parabola that we've seen a number of times now. Okay, so here's our original graph, y equals f of x. To sketch y equals the square root of x, let's start by considering that we can ignore anything that lies below the x-axis, because these points here all have a negative value of y. We can't take the square root of that. Now let's go for some easy points. The zeros are going to stay the same, because here the y value is 0 and the square root of that is 0. Same here. Also, let's look out for where y is 1. So looking across from y equals 1, I can see that happens here and here. So the square root of 1 is 1. So my new graph is going to go through all of those 4 points. So start by putting those dots down. Now we can consider other things like, okay, the square root of 4 is one that I know. The square root of 4 is 2. So when y equals 4, which happens for an x value, well, just to the left of that y-axis, I know that my new graph is going to be sitting at 2. So I can put a dot there and over here, there. All right, think about what's going to happen next. As we go up to really large values here, the next one I might be thinking of is, say, y equals 9, because I know the square root of 9 is 3. So where are we going to meet 3? Well, not till we're up here at somewhere about 9. It's going to happen around about here. So I'm going to end up with something, a 3 sort of around there. And that helps me to sort of reason with what's happening with this shape. Coming up like this and going out. Now you can see that in here, my red line is sitting above, just above my black line, and same over here. Whereas once we are at y values greater than 1, my red line for my new graph, y equals the square root of f of x, is going to always sit below that black graph, y equals f of x. And we've got a gap here. So if we were looking at the domain of this new function, we'd say that x is less than or equal to 1 or greater than or equal to 3. Let's have a look at what happens with a couple of different types of graphs. Here we've got the basic straight line y equals x. Now we know we can ignore anything that's below the x-axis because we can't take the square root of a negative number. We also know that zeros are going to remain as zeros, and when y equals 1, it will still equal 1 with our new function. We've also seen that our new function is going to sit above our y equals f of x function when y is anything between 0 and 1. And that's because when we take the square root of something like, say, a quarter, we get a half. So if I look for where y is a quarter, here, it's around about this sort of value here for x. For our new graph, we're going to be sitting up here at y equals a half, so I can put a little dot there. Now I can join this up with a sensible sort of curve. I want to sort of see where I'm going. How about we look for our next key point? When y equals 4 on the old graph, it's only going to be 2 on the new graph because the square root of 4 is 2, so I can put a dot. And that helps me join up the dots that I already have into something of a logical sort of shape. Now, we've already seen this graph before. We can work algebraically as well and say this is y equals the square root of x. Now, to see what this graph is a little bit like, we could square both sides and say it's a bit like y squared equals x. See, I've squared the left and squared the right. Except that this graph would have another arm that comes down the other side here. It's basically a parabola on its side, isn't it? Why is our graph not going down below? Well, because it's not plus or minus the square root of x. It's just the positive one. And so that tells us that y has to be positive and we only want the upper arm. And now looking at this cubic curve, we can see that the easiest way to work with it is to ignore anything that's below the x-axis. Put in our new zeros wherever there are zeros on the original function. Find wherever y is equal to 1 on the old function because they will be key points also on our new function. So if y is 1, we've got something about here and around about here. Now you'll see this is a sketch, it's not a perfect drawing, so near enough is good enough when we're doing this. We're sort of looking for the shape. We also know that between 0 and 1, the new curve is going to lie above the old curve. But from there on, as we go into higher y values, it's going to lie below. Now let's look for some other key points. So when y equals 4, well that happens here. Our new value is only going to be 2 because the square root of 4 is 2. So at that height of 4, we're sitting around about here. So now I can pretty well just start joining up some of the dots that I've got here. I can see that for these y values, my new curve needs to sit below the old one. But between y values of 0 and 1, it's going to need to sit above. Now, as I have a minimum turning point here, I'll need to keep it as a minimum turning point, but then it can come and sit up above like this. And if y is 4 around about here, it's going to be 2 now. So I've got something that looks roughly like this. Now, it's not perfect. It ends there. But in this direction, it's going to go on forever. So I'd say the domain of this function is whatever this point is, from there onwards, all those values of x. And values of y, well, y has to be at least 0 or upwards.